All right, in this video, we're going to be taking a look at a piece by Val Dusek called The Definition of Technology. So the point of this piece is to examine and evaluate different definitions of technology. So this is important for a couple reasons. Number one, in philosophy, it's really important to define our terms. Because what often happens in just regular debate and discussion is people, if they mean something different by the same term, they end up talking past each other. So it's kind of a waste of time. So it's important to get an idea of what exactly we're talking about so we don't end up talking past each other. Now, what we're going to do here in this when looking at this piece is we're not trying to figure out what is the correct definition of technology. I would say that whatever definition is appropriate is going to depend on the context and the purpose of inquiry. So let's just take a different subject matter as an example, environmental ethics. So in environmental ethics, it's important to define nature, but there's lots of different definitions of nature, and they can be just as good as the other depending on the purpose of the inquiry that you're using the definition in. And so in environmental ethics, we often use the definition of nature as anything that is separate from human beings in some kind of way, because the point of environmental ethics is to look at humans' relationship with nature. So that presupposes the separateness. But there's other forms of, there's other definitions of nature that may be just as good depending on, the context. So again, the point here isn't necessarily to exactly identify the correct definition of technology, but rather the point here is to just look at the different definitions and accounts of what technology is and evaluate those. And that in itself, I think, will be a valuable exercise. Now, before we get into all the different accounts of what technology is, it will be helpful to give some guidelines. So these are the standards against which we can evaluate a definition, how good the definition is. Okay, so the first standard or guideline is that definitions should not be circular. To put this another way, the definition of technology should not contain the term technology or some derivative of the term technology. So an example of a circular definition would be something like this. Technology is the branch of knowledge that deals with the creation and the use of technical means and their interrelation with life, society, and the environment. Okay, sounds good at first, but then when you listen closely or look closely at that definition, it contains technical means. Technical is just a derivative of technology. It's a form of the term, so it actually contains the term. It's a circular definition. It's not very helpful. So make sure that the definition is not circular. Also, definitions should not use figurative, emotive, or metaphorical terminology. That's great for literary work and poetry, but with analytical philosophy, we need to be highly literal and precise. So an example of this, an example of a definition of technology that's maybe figurative or emotive is to say something like technology is the death of nature, or technology is the opiate of the technocrats, or something like that. So not a very good definition. It's metaphorical, figurative, and therefore vague. So it's pretty vague, or as some philosophers might say, it's very mushy. It's a mushy definition. So you don't want your definitions to be mushy. Okay, so the third guideline is that the definition should not be negative. And by negative here, we mean it in the scientific sense. So by negative, we don't mean bad. We just mean like the absence of something. So think about in psychology, negative reinforcement. Negative reinforcement does not mean punishment. It means reinforcing a behavior by taking something out of the environment. So to put this another way, the definition of technology should not be what technology is not. So if you define technology as technology is not art or not religion or not science or not whatever, not very helpful, not a very helpful definition. So the fourth guideline is that the definition should not be too broad, cast its net too wide, but also not too narrow. And as we're going to see when we go through these definitions, This is a big one that can be pretty difficult to meet. Many of these definitions are either too broad or too narrow. Let me give you an example of a definition that's too narrow. So some people might say, well, technology means electronic or computer technology. Well, that's way too narrow because there's things outside of that scope that intuitively are very much technology, um, like a button. I mean, a button is a technology. It was something that was invented. We might not think of it as so, but or a light bulb, or a pencil, you would consider technology feasible enough, and so on. There are a lot of things that are not even electronic that could still be considered technology. So some have defined technology as all of culture. So that would be way too broad of a definition because it's not distinguishing technology from things like art or education, etc. So that would be way too broad. So the definition needs to be just right, not too broad, not too narrow. Now, when we start approaching these different definitions of technology, the first thing we can do before that is look at the different approaches to even trying to define something. So there's these different philosophical approaches. Now, one approach, which is probably the most ancient approach, it goes back to Aristotle and Plato and Socrates, is you might say, well, if you want to find the definition of technology, we need to find the real definition. So the real definition attempts to capture the essence of the thing. The essence of the thing is, in reality. So when you try to identify the real definition, you are basically doing metaphysics. Metaphysics is the study of the nature of reality. So if we apply this to technology, we would say, okay, what are the necessary and sufficient conditions of X such that X equals technology? So that would be sort of this real definition approach. Again, real definition approach, you're doing metaphysics, you're trying to find the essence of the thing itself that the term refers to. Now, since then, you see this with postmodernism and other approaches, social constructivist approaches. Many philosophers reject the idea that there is an essence to many things or everything. You might say, well, there isn't really an essence of technology, so we just can't get a real definition. This approach, you would try to find the nominal definition. So this is you might say, the conventional definition of something, and it rejects the idea that there's, an essence to a thing. So when trying to identify the nominal definition, we're not really doing any metaphysics. So just to kind of give you a more concrete example of the distinction between real definitions and nominal definitions would be the term water. Okay, so the nominal definition of water is, well, water is H2O. So when we cite a nominal definition, often we're citing a synonym. Now contrast that with the real definition of water, which is water is a compound made up of 2 hydrogen atoms and 1 oxygen atom. So that seems to be getting at the reality of it, the essence of it, assuming there is such a thing. Okay, so that brings us to lexical definitions and precising definitions, which are similar to nominal definitions. Both of these lexical and precising definitions, they're not worried about trying to identify the essence of the thing. They may even reject the idea that there is an essence of technology, for example. So you're not really doing metaphysics with these two approaches. Lexical definitions, they describe the meaning of a term according to the common usage of that term. How do we, competent language users, how do we commonly actually use this term in everyday situations? So that's the lexical definition. Now, one thing that may be a disadvantage to this, maybe, is that lexical definitions change over time because our usage of terms change over time. An example would be the term literally. So the term literally used to mean actually. So if you say something like, oh, he literally broke his arm, what that means is he actually broke his arm. But many people started using this term over the years incorrectly, quote unquote, to emphasize something. Because of that, the definition has actually changed. The lexical definition has changed a little bit to add this new meaning to literally, in this new meaning of literally is to add emphasis to something like I was so scared I literally passed out. Well, under this usage, you didn't actually pass out. It's just an emphasis that you were really, really scared. So that's an example of just how lexical definitions can change over long periods of time. And you might say that's a downside. But if you don't believe that there are essences of, like, say, technology, then you might say, well, that's the best we're going to do, or at least that's a starting point. And so many philosophers would say, okay, we need at least a starting point to get us off the ground when defining something. We might start with a lexical definition, and then we might move on to a precising definition, which is like lexical, but it kind of cleans up any vagueness just to make it more precise. And often philosophers will start with the lexical definition and then make it more precise and clean it up for the purpose of whatever it is that they're doing, that they're investigating. But I would say for our purposes for this class, we're really going to distinguish real definitions from the rest of these. So we're going to kind of chunk these three together, nominal, lexical, and precising, since they're all very similar, and contrast that with real. The basic difference is that the real definition is looking at for the essence of something, and the other ones are not really looking for the essence of a thing. Now that we've looked at the different approaches to formulating a definition, we can get into the actual definitions of science that we've seen throughout the years. So one definition that we can start with is to say technology is applied science. So we're defining technology as applied science. So for example, computers are technology. Well, what does that mean? It means that we've taken science, mathematics and logic on the software side, material science, looking at how electricity is modulated by certain materials. You take those sciences and you apply them in the world, and then you build a computer. So it's applied science. Unfortunately, this doesn't have, this has a number of problems. So for one, there are many tools that predate science. There are prehistoric tools such as axes and baskets and things like this that would be considered, commonsensically, would consider it technology, but surely wouldn't be applied science since it predates science. Another problem with this definition is that there are a lot of technological inventions that were not guided by science. So, for example, around the Industrial Revolution in the 1800s, a lot of those technologies were developed by tinkerers. They didn't really know science that well. They weren't really applying the science of the day, which was Newtonian physics. They would just tinker around with things and then invent things. So this doesn't seem to fit the definition of applied science. Similarly to that, there are a lot of technologies that weren't made by applying science, but were created by accident. They were discovered by accident. So, for example, Scotchgard, which is a thing you can put on like upholstery or fabric to protect it. It was discovered when this physicist or a chemist accidentally spilt this chemical on her sneakers and then noticed that it kept grime and things like that off of it. So it's not really applied science. It was just discovered by accident. So we can see that this definition is too narrow, because there are things that really seem like they're technology that are outside of that definition. Another definition of technology is to define technology in terms of hardware. So just to make this more concrete, think of the difference between hardware and software with computers. The hardware is the actual tangible computer, the screen, the circuits, all that. And then the software are like the applications or apps, the operating system, and so on. So this definition says, well, technology is hardware, or certain kinds of hardware. The problem with this, like the previous, is it's a bit too narrow. There are things that we commonly say are technology that don't fit that definition, that are outside the scope of that definition. So here are a couple problems. So one problem with this definition is that the physical hardware is not enough. It's not sufficient for there to be technology. Just to quote the author here, without knowledge of what the technology is and how to use it, the technology as technology is a meaningless object. So here are a couple examples of that. So the famous movie 2001 Space Odyssey begins with this, and you see it throughout the movie, this monolith, this like statue thing that just appears in the land, and these humanoids see it, and they just see it as like this weird object to like maybe to be worshipped, or some monument or something like that. And even more modern humans see it as that on this other planet, like they don't know what it is. And so it's to them, it's just like maybe a monument, maybe a piece of art, when really some aliens put it down there and it actually has this function to it. Um, so that's one problem with the technology definition. It seems like in order for something to be technology, to be considered technology, you need to know that it has some sort of use or some sort of function, maybe some idea on how to use it, or at least know it has some function. Okay, another problem, and I would say this is more severe to the definition, is technology really doesn't seem to need hardware or physical objects at all. And there's a couple examples of this. Think of B.F. Skinner, the famous behaviorist, who developed a way of conditioning, manipulating, changing patterns of behavior through certain means. This is a kind of behavioral engineering, and he actually kind of considered himself a kind of engineer. Many would say, well, yeah, this is a kind of technology, a technology that can be used to change behavior, but it's not a physical object. It's not hardware. And another example of this would be what I started with, the difference between hardware and software. Software would be the programs in a computer. Or you could even think of artificial intelligence. That's not really a tangible thing. It's inherent in tangible things in computers and data centers and things like that. But the actual processes involved, it's not an actual piece of hardware. So this definition seems to be problematic because it's too narrow. There are things that we would consider technology that don't fit that definition, that are outside the scope of that definition. Another definition of technology is to understand technology as rules or as technique. So we can understand technology as a certain kind of rule or set of rules, or a certain kind of activity. Much of this comes from a French philosopher named Jacques Ellul, who says means and activity is the core of technology. So this comes out of a rich tradition of critical social theory, which stems out of Karl Marx critiquing socioeconomic relations of capitalism. And many of these critical theorists will say, well, one thing that's essential to capitalism is that it sort of fosters this ideology where we start to see everything in terms of means to an end, and that kind of influences our thinking. So this is a kind of activity in which everything is done for the sake of some end, whether it be profit or fulfilling interest or something like that. So, and again, here the idea of technology is that it's an activity. It's some kind of means and activity or set of rules. Max Weber, who was a sociologist, had a similar view. And just to quote him, he says, as society develops, more and more aspects of social life become systematized in terms of systems of rules. So these systems of rules, under this definition, would be considered technology. So the advantages is this is consistent with software being technology. It can incorporate software as technology, which is becoming more and more prevalent in society. So software, you might even consider artificial intelligence as part of this. But some problems may be that it could be a bit too narrow in that it downplays the physical embodiments of technology, the hardware part of it. But in another sense, it may be too wide. So it may incorporate things as technology that really don't seem like technology, like self-help books with rules to live by, right? That's techniques to live by, or a set of rules. But many would say self-help books with rules to live by wouldn't really be considered technology. But this is debatable. Ellul would respond by biting the bullet and saying, well, no, I mean, there's just a lot of technology in the world today. So again, a lot of these things at this point, a lot of these definitions are up for debate. We'll look at the advantages and disadvantages. Okay, we've arrived at the final definition of technology. And this, I'll start off by saying, has become the consensus definition. So this is the broad definition that many philosophers of technology use, most seem to use. It has its, like all of them, it has its benefits and problems. But this basically says that technology should be understood as a system. So just to quote the text, the technology is the application of scientific and other knowledge, not just scientific, to practical tasks by ordered systems that involve people, organizations, production actions, skill, living organisms, and machines. So again, pretty wide scope definition here. So just to give you an example of defining a technology in these terms and systems terms is the power grid. So the power grid is this system made up, it's not just generators and power lines, but a system of interrelated components, which consist in the power plants, coal, nuclear, solar, wind, and the systems in those power plants, then transmission and distribution of the infrastructure, regulatory bodies, safety standards, all the skilled laborers involved, the engineers, the linemen, the operators, the billing systems, the market, the consumers, patterns of consumer practices. So here you can see how we're defining the power grid in terms of this system. And again, these interrelated components that all kind of work together, often understood not just in terms of the components themselves, but the relation between the components. And this understanding of technology has come out of a couple different traditions. It's come out of the social constructivist understanding of technology. And the social constructivists will say that the ideas at the basis of technology are socially constructed in some sense. This understanding of technology has also come out of more postmodern understandings of technology. According to this approach and postmodernism in general, there is no essence to technology or to anything really in the Platonic sense, Plato's sense. Postmodern understanding embraces many different meanings of technology. It's pretty wide open. An example of this would be actor network theory by Bruno Latour. So he describes all the actors and entities involved in the invention, use, consumption, and interpretation of technology, and all the intricate web of their interactions. So if you want to understand technology, you need to look at all that stuff. So very comprehensive. And again, this has become the consensus definition. So there's some perhaps there are problems with this. You might say it might be a little bit too wide scope, like, well, then everything's technology maybe, but we'll just leave that as it is. Now let's summarize. The aim of this video was to evaluate different definitions of technology. We started out with some guidelines, like the definition shouldn't be too vague or metaphorical, and it shouldn't be too narrow, too wide. And those guidelines can apply to coming up with any definition. Then we looked at the different philosophical approaches, and the main distinction we made was between the philosophical approach that tries to find the real definition versus the nominal definition, or lexical or precising. We kind of lumped all those together. And again, the basic distinction here is that the real definition tries to get at the essence of something. So you're doing metaphysics when you're looking at the real definition. But the others, you're not really looking at the essence, you're looking at something else, like how it's used in everyday language. So those are the two main broad philosophical approaches we looked at. And then we actually looked at the definitions of technology. We saw technology as applied science, technology as hardware, technology as rules or technique, and then technology as system, which kind of incorporates elements of those previous three and is the sort of consensus definition of technology.